Welcome all. Today let us study about the interior structure of the earth. On the basis of the study of the seismic waves and seismic tomography, it may be concluded that the earth has several density zones inside. The behavior of seismic waves and the tomographic analysis proves beyond doubt that earth consists of three layers: the crust, the mantle and the core. A brief description of these three layers has been presented below. Compositional layers of the earth. Core, mantle and crust are division based on composition. The crust makes up less than 1% of the earth by mass, consisting of oceanic crust and continental crust, is often more felsic rock. The mantle is hot and represents about 68% of the earth's mass. Finally, the core is mostly iron metal. The core makes up to 31% of the earth. First, let us know about the crust. It is the outermost solid part of the earth, normally about 8 to 40 kilometers thick. It is brittle in nature. Nearly 1% of the earth's volume and 5% of the earth's mass are made up of the crust. The thickness of the crust under the oceanic and continental areas are different. Oceanic crust is thinner. It is about 5 kilometers as compared to the continental crust. It is about 30 kilometers. Major constituent elements of the crust are silica and aluminium, and thus it is often termed as shale. Sometimes shale is used to refer lithosphere, which is the region comprising the crust and the uppermost solid mantle also. The mean density of the material in the crust is 3 gram per cubic centimeter. The discontinuity between the hydrosphere and the crust is termed as the Conrad discontinuity. Next, mantle. The portion of the interior beyond the crust is called as mantle. The discontinuity between the crust and mantle is called as the Mohorovic discontinuity or Mohr discontinuity. The mantle is about 2,900 kilometers in thickness. Nearly 84% of the Earth's volume and 67% of the Earth's mass is occupied by the mantle. The major constituent element of the mantle are silicon and magnesium. Hence, it is also termed as SEMA. The density of the layer is higher than the crust and varies from 3.3 to 5.4 gram per cubic centimeter. The uppermost solid part of the mantle and the entire crust constitute the lithosphere. The asthenosphere, it is between 80 to 200 km, is highly viscous, mechanically weak and ductile, deforming region of the upper mantle which lies just below the lithosphere. The asthenosphere is the main source of magma, and it is the layer over which the lithospheric plate, that is the continental plate, move. The discontinuity between the upper mantle and the lower mantle, known as Repeti discontinuity. The portion of the mantle which is just below the lithosphere and asthenosphere but above the core is called mesosphere. Next, core. It is the innermost layer surrounding the Earth's surface. The core is separated from the mantle by Gutenberg's discontinuity. It is composed mainly of iron and nickel, and hence it is also called Nephi. The core constitutes nearly 15% of Earth's volume and 32.5% of Earth's mass. The core is the densest layer of the Earth, with its density ranges between 9.5 to 14.5 gram per cubic centimeter. The core consists of two sublayers, the inner core and the outer core. The inner core is in solid state and the outer core is in liquid or semi-liquid. The discontinuity between the upper core and the lower core is called Lehman discontinuity. Barysphere is sometimes used to refer the core of the earth or sometimes the whole interior. Next, Next, temperature, pressure and density of the earth's interior. Temperature. The rise in temperature with increase in depth is observed in mines and deep wells. These evidence, along with molten lava erupted from the earth's interior, support that the temperature increases towards the center of the earth. The different observations show that the rate of increase of temperature is not uniform from the surface towards the Earth's center. It is faster at some places and slower at another places. In the beginning, this rate of increase of temperature is at an average rate of 1 centigrade for every 32 meter increase in depth, while the upper 100 kilometers the increase in temperature is at the rate of 12 centigrade per kilometer, and in the next 300 kilometers it is 20 centigrade per kilometer. But going further deep, this rate reduces to mere 10 centigrade per kilometer. The temperature at the center is estimated to lie somewhere between 3000 centigrade and 5000 centigrade, may be much higher due to the chemical reaction under high pressure condition. Even in such high temperature also, the materials at the center of the earth are in solid state because of the heavy pressure of the underlying materials. Next, pressure. Just like the temperature, the pressure is also increasing from the surface towards the center of the earth. It is due to the huge weight of the overlying materials like rocks. It is estimated that in the deeper portion the pressure is tremendously high, which will be nearly 5 to 4 million times more than the pressure of the atmosphere at sea level. At high temperature, the materials beneath will melt towards the center part of the earth due to heavy pressure. These molten materials acquire the properties of solid and are probably in a plastic state. Next, density. Due to increase in pressure and presence of heavier metal like nickel and iron towards the center, the density of Earth's layer also gets on increasing towards the center. The average density of the layers getting on increasing from crust to core, and it is nearly 14.5 gram per cubic centimeter at a very center. Next, sources of information for the study of Earth's interior. First, let us know about the direct sources of information about the Earth's interior. Deep earth mining and drilling reveal the nature of rocks deep down the surface. But as mining and drilling are not practically possible beyond certain depth, they don't reveal much information about the Earth's interior. Mopang gold mine, it is the deepest mine in the world, and Tautona gold mine, it is the second deepest mine in the world in South Africa, a deepest mine reaching the depth of only 3.9 km. And the deepest drilling is only about 12 km deep hole bored by Soviet Union in the 1970s over the Kola Peninsula. The volcanic eruption forms another source of obtaining direct information. Next, indirect source of information about the Earth's interior. By analysis, the rate of change of temperature and pressure from the surface towards the interior. Next, meteors, as they belong to the same type of materials Earth is made of. Next, gravitation, which is greater near poles and lesser at the equator. Next, gravity anomaly, which is the change in gravity value according to the mass of material, gives us information about the materials in the Earth's interior. Next, magnetic sources. Magnetic survey also provide information about the distribution of magnetic materials in the crustal portion and thus provide information about the distribution of materials in this part. Next, seismic waves. The shadow zone of body waves, that is primary and secondary waves, gives us information about the state of material in the interior. Let us know about the relevance of seismology in the study of interior of the earth. Seismic waves are the waves of energy that travel through the earth as a result of an earthquake and can tell a lot about the internal structure of the earth. Because these waves travel in different speed in different materials. There are two types of waves and travel through the earth. They are P waves and S waves, that is primary waves and secondary waves. Primary waves are faster and they can travel through both solids and liquid. Secondary waves are slower and cannot travel through the liquid. For both kinds of waves, the speed at which the wave travels also depends on the properties of the material through which it is traveling. Thus, if there is an earthquake somewhere, the first waves that arrive are P waves. In essence, the gap in P wave and S wave arrival gives a first estimate of the distance to earthquake. Scientists are able to learn about Earth's internal structure by measuring the arrival of seismic waves at stations around the world. For example, they know the Earth's outer core is liquid because S waves are not able to pass through it. Seismic waves travel in curved paths through the earth, that is because of the increasing pressure and materials are more dense towards the core. Travel velocity of seismic waves increases. Refraction of seismic waves causes them to curve away from the direct path. Reflection causes them to glance off certain surfaces like core mantle boundary when they hit it at too shallow of an angle. The result of this behavior, in combination with the fact that S waves cannot travel through the liquid, is the appearance of seismic shadow opposite to the actual earthquake site. When the earthquake occurs, there is a shadow zone on the opposite side of the earth where no S waves arrive. Similarly, Earth has a solid inner core, but some P waves are reflected of the boundary between the inner core and the outer core. By measuring the time it takes for seismic wave to travel along many different paths through the earth, they figure out the velocity structure of the earth. Abrupt changes in velocity with deep corresponding to the boundaries between different layers of the earth composed of different materials. Let us know the importance of studying interior of the earth. We rely on earth for valuable resources such as soil, water, metals, industrial minerals and energy, and we need to know how to use these resources and exploit them sustainably. We can study rocks and the fossils they contain to understand the evolution of our environment and life within it. We can learn to minimize our risk from earthquake, volcanoes, slope failures and damaging storms. We can learn how and why Earth's climate has changed in the past and use that knowledge to understand both natural and human caused climate changes. We can recognize how our activities have altered the environment in many ways and the climate is increasingly serious ways and how to avoid more severe changes in the future. We can use our knowledge of Earth to understand other planets in our solar system as well as those around distant stars. In the next class, let us study about the geological history of the Earth. Thank you.